In this video, you're going to learn how to blink an LED with the Arduino. LED stands for Light Emitting Diode, so it's a diode that emits light. LEDs have polarity, which means they allow current to flow in one direction, from positive to negative. The LED shorter lead is called the cathode, and the longest lead is called the anode. The anode should be connected in the direction of the positive supply and the cathode to ground. LEDs like these draw approximately 200 mA. So, when connecting LEDs to the Arduino, you need to add a resistor in series with the LED. The resistor is a component like this that will limit the amount of current reaching the LED. In this case, we're going to use a 220 ohm resistor. Different resistors have different color bands. That's how you identify them. Search on the web for resistor color code to help you identify different resistors. Now that you know what an LED is and how it works, let's make the circuit on a breadboard. A breadboard gives you an easy way to build circuits without having to connect the components using solder, so it's perfect for prototyping. This breadboard has two rails on each side. These are the power rails and are used to connect ground and power to your circuits. In the middle of the breadboard is where you place your components. The breadboard has many tiny holes that are electrically connected this way. Now let's start wiring the circuit. You can pause the video and follow the on-screen schematic instead. Start by inserting the LED on the breadboard this way. Then insert the 220 ohm resistor into the breadboard so that one side is connected to the LED anode, the positive lead. With a jumper wire, connect the other side of the resistor to pin 13. Finally, connect the LED cathode, the shorter lead, to ground. That's it, your circuit is ready. Now you only need to upload an Arduino sketch to your board to make the LED blink. Having your Arduino connect to your computer with a USB cable, open the Arduino IDE and copy the sketch provided. This sketch blinks the LED every other second. These lines in gray color are comments. Comments are plain English or any other language and start with the double slash symbols. Any text after the double slash is ignored by the Arduino. Let's see how the code works. Here we create a variable called LED pin and assign it to 13, which is where the LEDs connect to. From now on, every time you use the LED pin variable, you'll be referring to pin 13. In the setup, this line sets pin 13 as an output, indicating we want to send power to the LED. For this, you use the pin mode function. This function accepts the pin and the mode as arguments, as we're doing here. In the loop is where you'll actually blink the LED. We need to turn it on for 1 second and off for another second. To set a pin state, you'll use the digital write function and between parentheses the pin you are referring to and the state. The state can be either high, turning the LED on, or low, turning the LED off. So, to turn the LED on, you should write digital write LED pin high. We want the LED to stay on for 1 second, so we use the delay function here that accepts an integer as an argument. This number represents the time in milliseconds the program will wait until moving on to the next line. Here we're using 1000 that corresponds to 1 second. After that second is passed, you need to turn the LED off. Once again, you use the digital write function, but this time you set its state to low, which turns the LED off. Finally, we wait another second using the delay function. This part of the code will run over and over again, which makes the blinking effect. Upload the code to your Arduino as you've done in the previous video. Make sure you have the right board and COM port selected. After uploading the code, look at your LED. It should be blinking every second. Now you can play with the delay time and see how it works. For example, change to 500 milliseconds or to 100 milliseconds so it blinks faster. In summary, you can use the concepts learned in this video to make multiple projects with LEDs or control practically any other output.